Hello, students. Welcome to the course on Engineering Geology and Hydrology. Today, we will delve into the study of Chapter 3, Fracture Structures. Such structures significantly impact our engineering construction. Does everyone remember the Wenchuan earthquake? The occurrence of this earthquake was greatly related to the structure of the Longmingshan Fault. We will cover fracture structures in 2 lessons. Today, we focus on the definition of fracture structures, the geometric elements of faults, and the basic types of faults, with a particular emphasis on the basic types of faults. Firstly, let's examine fracture structures. A fracture structure refers to the rupture that occurs in rocks under stress, disrupting their continuity and integrity. Fracture structures include joints and faults. A joint is where the rocks on either side of the ruptured surface have not experienced significant displacement, whereas a fault is characterized by significant relative displacement of the rocks on either side of the ruptured surface. Thus, we distinguish joints from faults primarily based on whether there is a noticeable relative displacement of the rocks on either side of the ruptured surface. If no significant relative displacement is observed after the rock rupture, it is a fault. Faults not only significantly affect the stability and permeability of our structures and seismic activity, but also greatly impact our engineering construction. Hence, we will concentrate on studying faults today. Secondly, the geometric elements of faults. The geometric elements of a fault include the fault plane, fault zone, fault line, and fault blocks. The fault plane is the ruptured surface where the 2 displaced rock blocks slide relative to each other, as indicated in the diagram on the right, which we refer to as the fault plane. The fault zone is where the movement on either side of the fault does not occur along a single plane, but along a fracture zone composed of many fractured surfaces. We call this zone the fault zone or fault belt. The fault zone often forms mudstone, fault breccia, and fault gouge. 3. The fault line refers to the line where the fault plane intersects with the ground surface. In other words, referring to the right figure number 3, this red line is the fault line. The fault block refers to the rock masses on either side of the fault plane that move relative to each other, which we call the fault block. The fault block can be divided into the hanging wall and footwall. The hanging wall refers to the area above the fault plane, which is our hanging wall. For example, the rock mass 2 is above 4, so we call 2 the hanging wall. As for the footwall, it is beneath the fault plane. 1 is below 4, so 1 is our footwall. This is something we need to clearly distinguish, which is the hanging wall and which is the footwall. Thirdly, the basic types of faults. Based on the relative displacement of the 2 sides of the fault, we can classify faults into 3 basic types: normal fault, reverse fault, and strike-slip fault. Different types of faults directly affect the nature of the fault. Therefore, in the field, we need to learn how to distinguish between normal faults, reverse faults, and strike-slip faults. A normal fault is one where the hanging wall moves downward relative to the footwall along the fault plane. For instance, taking the animated diagram on the right, first, from the diagram on the right, we can see that the block on the left is below the fault plane, while the block on the right is above the fault plane. Therefore, the left is the footwall, and the right is the hanging wall. We can clearly see that the footwall on the left is moving upward relatively, while the hanging wall on the right is moving downward relatively. Hence, it is a normal fault. A normal fault is typically formed under the influence of horizontal tensional stress, where the hanging wall slides down relatively. A reverse fault is one where the hanging wall moves upward relatively along the fault plane, while the footwall moves downward. For instance, taking the animated diagram on the right, the block on the left is below the fault plane, which is the footwall, while the block on the right is above the fault plane, which is the hanging wall. we can clearly see that the left foot wall is moving downward relatively, while the right hanging wall is moving upward relatively. Hence, it is a reverse fault. A reverse fault is typically caused by intense compressive forces acting horizontally on the rock body, causing the hanging wall to move up along the fault plane. A strike-slip fault refers to a fault where the two sides basically move horizontally relative to each other along the line of the fault. For example, in the animated diagram on the right, there is no relative upward or downward movement of the two sides, but rather a horizontal shift. The first step we call this type of fault a strike-slip fault is to find the fault plane. We can easily locate the fault plane, which is this extended area. Then, we need to determine which is the hanging wall and which is the foot wall. The block on the left is below the fault plane, so it is the foot wall. The block on the right is the hanging wall. Looking at the hanging wall, has it moved relatively downward? And the foot wall, has it moved relatively upward? Hence, the photo on the left is a normal fault. Let's take a look at the photo on the right. In the photo on the right, we can see that the left side is the foot wall, while the right side is the hanging wall. Then, has the hanging wall on the right moved relatively upward, while the foot wall on the left has moved relatively downward? When the hanging wall rises and the foot wall descends, that is a reverse fault. Thus, we determine whether it is a normal fault or a reverse fault, based on the relative displacement of the two sides. In this lesson, we mainly learned about the definition of fracture structures, geometric elements of faults, including fault planes, fault zones, fault lines, and fault blocks, as well as the basic types of faults, namely normal fault, reverse fault, and strike-slip fault. The key is to learn how to distinguish between normal faults, reverse faults, and strike-slip faults. In our next lesson, we will cover the combined types of faults and how to identify faults in the field. See you in the next lesson.